Hello, today is May the 1st, and we're going to be doing advanced concept presentation number 7, almost done, so molecular geometry. So first we will just start with what our supplies are going to be, and really this week all we needed were some balloons. So let me kind of get those balloons together and then we will begin. All right, so first we're just going to start off very simple. First one, we have our linear molecule, or our linear geometrical shape. It's only going to have 2 electron domains. An example of this is going to be CO2, and this little loose dot structure here will kind of show you. We've got 2 things connected to the center atom, and we don't have any lone pairs for this one. So here I have started and I've pre-blown up my balloons for us today, and so this is just an example of our electron domains in a linear geometrical shape. And so for all of these I have pre-blown up the balloons, and I started out really big, and then as we get more electron domains, the balloons will get smaller, just simply because it's easier to tie them together when they're a little bit smaller. So up next, we are going to start with this. I don't know if you can read it. I don't know if it focused. Trigonal planar electron domain geometry. It has 3 electron domains, and the type of molecule is an AB2. An example of this one is going to be SO2, and this example is going to have 1 lone pair, and so it's going to be bent. So as you can see, it still has the 3, 1 with your lone pair, and then 2, 3 things attached to our center, so that's why it has 3 electron domains. And that's going to be your trigonal planar. So let me show you that one. This could be our purple balloons. And as you can see, there's 3 electron domains, and those electrons are going to push away from each other as far as they can. So this one's just going to be like this. Trigonal planar. And we'll kind of get rid of those as we go. Third, we are going to talk about our tetrahedral. There's going to be a few different types on our tetrahedrals, and they're all going to have that 4 electron domains with them. And so this is an AB3 molecule, tetrahedral shape. An example with no lone pairs is going to be CH4, and so that's just going to be your normal tetrahedral shape. An example with 1 lone pair is going to be your NH3, and I have drawn your little Lewis structure there, and so you can see you have 1, 2, 3, and then you have 4 electron domains attached to your center atom. And so when it has that 1 lone pair, it's going to be trigonal pyramidal. And that just has to do with how these lone pairs are pushing against these other electron domains. And so then your angles are going to be a little bit different with the lone pairs attached. So an example of that tetrahedral is going to be this. So we have 1, and there's one back here. 2, 3, 4. So we have 4 electron domains in our tetrahedral shape. And so like I said, there's going to be a few more with the tetrahedral. So we'll flip over here and we'll just talk about what if it has 2 lone pairs. And so if you have a tetrahedral atom or molecule with an AB3, but you have 2 lone pairs, an example of that is going to be H2O with water, because we have 1, 2, 3, and then 4, because those lone pairs act as an electron domain. So you're still going to have those 4 electron domains, but this is going to be a bent molecule. And so there you have water. And then we are going to move on to our 5 electron domains. And so we will start here, and this is going to be an AB4 molecule with our molecular geometry being trigonal bipyramidal. And this one has quite a few like variations with our lone pairs, but they will all come back and have that 5 electron domains. And so this one with no lone pairs is going to be PCl5. I've drawn the Lewis structure here. As you can see, there are 5 electron domains around it and no lone pairs. An example with no lone pairs, let me find it. And this is going to be our trigonal pyramidal, because we have 1, 2, 3, 4, 5 electron domains kind of just attached along the center point here. So there you go. And then we will kind of go on to the lone pairs of those trigonal pyramidals. So here's our example number 1. We have SF4. It has 1 lone pair, and that's going to create a seesaw shape. And so, like I said before, this is all going to have to do with your bond angles and those lone pairs and how those push against those other electron domains. But there's still going to be 5. And so you have 1, 2, 3, 4, and then you have this lone pair right here that's going to be 5. And that's going to create your seesaw shape. So now we will move on to another variation of this trigonal bipyramidal, and it is going to still have our 5 electron domains. It's going to be an AB3 molecule with a geometry of trigonal bipyramidal still, but with our 2 lone pairs. Here's an example. It's going to be ClF3, and as you can see in this Lewis structure, we have Cl, 1, 2, 3, 4, and 5 electron domains still, but this one's going to be T-shaped, and that's because you have the 2 lone pairs on top of that center atom. So ClF, our AB3 molecules with 2 lone pairs are going to be T-shaped, still with the 5 electron domains though. And so here, our last variation of our trigonal bipyramidal. We're just going to reiterate, we have 5 electron domains, but this one's going to be an AB2 molecule with a geometrical trigonal bipyramidal shape. But this one is going to have 3 lone pairs. So an example of that is going to be IF2, the ion with a negative charge. And so you have your I, and then you have your 2 Fs, and then you have 3 lone pairs on that center atom. And so when you have those lone pairs, like I said before, they're going to push differently on our electron domains and create a different shape. And so this one with our 3 lone pairs on our AB2 molecule with 5 electron domains is going to be a linear shape. And so there you have it. There are our variations of our trigonal bipyramidals with our 5 electron domains. And so last but not least, we will talk about our molecules with 6 electron domains. And so we'll just start, obviously 6, it's going to be an AB5 molecule with a geometrical shape of an octahedral. An example of this one with no lone pairs is going to be SF6. And as you can see in our Lewis structure, we are going to have 6 electron domains around our 1 center atom. And so that creates our octahedral. And so I have created in very small balloons an octahedral shape here. These balloons are not all the same size, but typically you would. So we have 1, 2, 3, 4, 5, 6, with all of these electrons repelling each other at equal distances, and so that's what we get. Obviously it's not to scale, especially with some of these balloons being a little bit bigger than the other, but They're all centered around that center point, repelling each other. And so that's our octahedral. And so now we'll talk about octahedral with one lone pair. That's going to be an AB5 molecule. It will still have the 6 electron domains. An example is going to be BRF5. Lewis structure here. You're still going to have the 6 electron domains because your lone pair counts as an electron domain. However, because it is a lone pair, it's going to push a little bit more on those electrons than a regular bond. And so you're going to have a different shape, which is going to be square pyramidal on this one. So, and then finally, we will get to octahedral with 2 lone pairs. This is going to be an AB4 molecule, 6 electron domains. An example is going to be xenon F4, XeF4. I drew the Lewis structure here where you're going to have the 4 bonds on the outside with 2 lone pairs. Still 6 electron domains, but the shape due to the lone pairs is going to be a square planar shape. So there you have it. There are all of our electron domain geometries. This is Advanced Interactive Concept Presentation number 7, and I'm Haley. Thank you so much.